Hey, does this look familiar? All right, let's put these organs in order. We're going to talk about activation and hormonal cascades in the endocrine system. Which comes first? And remember, with hypothalamic pituitary axis, it's always HP and then something target organ, right? So here we were talking about the testes in this example, but again, in the HPG axis, hypothalamus releases GnRH, gonadotropin releasing hormone. That targets the pituitary and stimulates the pituitary to produce FSH, follicle stimulating hormone, and luteinizing hormone. And then that targets the gonads. We're talking about the testes in this example. So the testes are going to produce testosterone. And this is what we call the HPG axis. Now with HPG axis, what we have is again GnRH stimulating the pituitary gland, then FSH and LH, and then with the ovaries and testes, well again, the testes primarily androgens, and these androgens and testosterone will be released into your bloodstream. Now this is the book's example. So again, same thing, organization is that HP and T axis, and what we have GnRH, stimulating production of SF, FSH, and LH. Now, we know it targets the testes, but now we're getting more granular and what specifically is being done. Luteinizing hormone targets those interstitial cells. Again, even though you can't see them in that microscope slide, they are important cells. Why? Well, LH stimulates these interstitial cells or Leydig cells to produce testosterone. So testosterone is again the primary male sex hormone, and all of these effects that are too small to see in the slides, but they're in your book. Again, things like libido, sexual drive, bone and muscle growth, and also secondary sex characteristics such as facial hair and widening of the larynx as well, and maintaining the organs of the reproductive system in men. But this is the other thing. Remember the negative feedback? So say you have too much testosterone in a man. Well, this testosterone, the more testosterone you have, the more negative feedback that's going to shut off production of gonadotropin releasing hormone. And this is where your book is inaccurate. It actually also inhibits the production of FSH and LH as well. So then testosterone this isn't in your book for some reason, but it actually has a double negative feedback loop or actually multi-pronged multi-feedback loop that hits both the hypothalamus and pituitary. So it's kind of like shut the double brake system that kind of prevents the production of more testosterone when you already have too much. Now FSH, what does that do? So the target of FSH are the Sertoli cells. So again, remember, they're the ones that help to promote sperm. They don't become sperm themselves, but they help sperm develop. They also produce androgen binding proteins. So remember, testosterone is a steroid. Steroids tend to be hydrophobic and not lipid soluble. So they don't easily dissolve in water. So what do you do when you're trying to dissolve a lot of testosterone in water? Maybe couple it with a protein that can dissolve in water that is hydrophilic. So this is what androgen binding protein helps to do, is transport testosterone. It also helps to inhibit testosterone as well, because the thing is that if this protein is holding onto testosterone, and then so the thing is that if it's holding onto testosterone, then the testosterone can't freely diffuse into cells. So it actually kind of inhibits it indirectly. But that's an androgen binding protein. But not only is that you have that, you also have it secreting another hormone called inhibin. And inhibin does inhibit the production of FSH and LH by inhibiting the production of it from the pituitary gland. And this part, your book has this question mark, and they're not sure if this happens. I think it's still kind of like the jury is still out whether that happens. But yeah, I'm surprised they omitted this part, but somehow included this part. I don't know, inconsistency, whatever. Okay, so why am I talking about testosterone? Well, primary and secondary male sex characteristics. So, what makes what makes him phenotypical male? Right. Okay, so why am I talking about testosterone? Well, now we have to talk about sex characteristics. So primary sex characteristics, well, the internal and external genitalia. So the actual form of actually the forming of the male genitalia or female genitalia, but we're talking about the males in this lecture. So this is what the primary sex characteristic. This is what makes a male a male. And then in secondary sex characteristics, what we're talking about? Well, the things that are not just exclusive to male, but typically associated. And you have things like wider shoulders, narrow hips, and pubic angles. And then you have increased muscle mass and bone density, facial and body hair, and increased sebaceous gland secretion. So this is why men smell a little stronger and a little oilier. And also larger larynx. That's why men on average have a lower voice. And again, due to the larger larynx and increased vocal fold length, and also the more slack in the vocal folds. And then what we have here, so androgens are such as testosterone. These play a primary role in the development of the secondary. And why? Again, androgens are produced by the primary, the testes, and due to the internal genitalia. But this causes all the development of all of this. So this is why when boys enter puberty, this is why they have changes in stature. They become taller, they become more muscular, they have more wider shoulders, and they might get facial and bodily hair. Have you ever seen like teenagers when they have that like kind of wispy mustache? But again, if they're not they haven't undergone puberty, they don't have that yet. And this is why they need more deodorant when they boys enter puberty. So virilization refers to this development of the secondary male sex characteristics. So these are the ones that develop after puberty. Again, before puberty, they still have the internal external genitalia, but they don't have this yet. And it's due to that increase in testosterone. Well, the increase of testosterone is one of many things, but it's one of the primary drivers in actually developing these sex characteristics. Now, here we have a sound sample. So who's singing this? And it does sound very distorted because this is an old recording. So this is the person singing it, Alessandro Moreschi, and he is a man. But back in the 18th century, so he was the last of the Sistine Chapel castrati. Castrati, that is the same root word as castration, so removing the testicles. So castrati, what did they do? They actually would remove the testicles before a boy entered puberty. So this is why he was able to hit those high falsetto notes. He actually never went under endocrine puberty. So then why? So if you remove the testes, what happens? Well, remove the testes, you're removing a primary source of androgens and testosterone. So then you don't get virilization. If you don't get virilization during puberty, this laundry list is wiped out. So you don't really get all of these. So he's clean shaven because he can't develop or significant coarse body hair or facial hair, but he also doesn't develop a larger larynx. So he basically has the larynx of a boy. And this is what they were trying to do with these castrati. They were trying to make them like have the stature of a man and grow up like a man, but also keep that larynx, that small larynx of a boy, so that they have clarity of voice and high pitch. Thankfully, they don't do that anymore. And the difference between castrati and eunuch is a eunuch just refers to someone who has their testes removed. But castrati, they were actually purposely doing this so that these boys wouldn't undergo puberty, and so they could maintain their voice and wouldn't have the change in voice after post-puberty due to the larger larynx.